So I'm going to go over some examples of solving linear inequalities. We're going to start off with like two-step ones and then build into different multi-step ones. So suppose we have something like negative 2x plus 3 is greater than or equal to 5. So we're going to solve this similarly to how we would if we have the equation negative 2x plus 3 equals 5. We're going to do the same steps. So if we had equals, we would probably start by subtracting off 3 from both sides, and we get negative 2x is equal to 2. And then we would end up dividing by the negative 2, and we'd get x is equal to negative 1. Well, we're going to take the same steps for the inequality, but we'll just have to watch out for the last step when we're multiplying or dividing if we have a negative number. So we'll add we'll subtract the 3 from both sides. And we get negative 2x greater than or equal to 2. And then we're still going to divide by negative 2 on both sides. And we'll get x on the left-hand side, and we'll get a negative 1 on the right-hand side. Now, since we are multiplying or dividing by a negative number, so this guy is negative, we're going to flip the inequality sign. So instead of having greater than or equal to, we're going to have less than or equal to. And this is going to be our solution. If we wanted to graph our solution, we would find negative 1 on the number line, maybe put some context to it. So I'll show that it's between negative 2 and 0. And over here is 1, and over here is negative 3. And we want to indicate all numbers that are less than or equal to negative 1, right? So our solution could be negative 1. So I'm going to put a circled in point there. And I'm going to bold all the numbers that are less than negative 1 as well. So I'll get this. And this would be the graph of our solution set. All right, next one. Suppose we have something like 2x plus 3 minus 4 plus 5x less than or equal to 6. We'll solve this the same way as if we had an equals instead of a less than or equal to. So if we had an equals, you would probably start by distributing the negative and then combining like terms. And so we're going to do the same thing. So I've got 2x plus 3, and I'm going to distribute this negative. So I've got minus 4 minus 5x, and then we've got less than or equal to 6. And then we combine like terms. So the 2x and the minus 5x give me minus 3x, and the 3 minus 4 gives me a minus 1. And we still have less than or equal to 6. Now we're at a two-step equation, and just like in the other one, we'll deal with our constant terms first. So I'll add 1 to both sides. So I get negative 3x less than or equal to 7. And then I'm going to divide by the coefficient of my x. Well, this one's a negative number, so I'm dividing by a negative 3. So I make sure that I flip my inequality sign. So instead of less than or equal to, I'm going to write greater than or equal to. And I've got negative 7/3. If I want to graph this, I just need to place negative 7/3 on the number line. So here I've got negative 7/3. I'm going to give some context as to where it is. So negative 7/3 is just like negative 2 1/3. So this is going to be between negative 3 and negative 2. And I can put some more numbers as well if I want. And now if I'm trying to indicate all numbers that are greater than or equal to negative 7/3, I will bold in right at negative 7/3 because I can be equal to it. And then I will bold in all the numbers greater than as well. All right, for the next one, suppose we have, negative 4x plus 5, 9 plus 3x is less than 2x plus 1. So this one looks pretty complicated, but you just chunk it piece by piece. So we're going to start by simplifying the left-hand side. So just focus on this part and simplify that first. Well, to simplify that, we would have to distribute the 5. So we've got negative 4x plus 45 plus 15x. And then we have less than 2x plus 1. And that the 2x plus 1 is already simplified, so we're just going to have it kind of hang out. Then we combine like terms. The negative 4x and 15x give us an 11x. And then we have plus 45 less than 2x plus 1. And now we're going to compare this to as if we had an equal sign right here. Well, if we had an equal sign right here, you would probably subtract off this 2x from both sides and kind of keep working down. And so we're going to do the exact same thing. We're going to subtract 2x, subtract 2x. And so we get 9x plus 45 is less than 1. And now we have a two-step inequality. So just like before, we deal with the constant. So we subtract 45 from both sides. We get 9x is less than negative 44. And then we divide by the coefficient of our x. And this time, we're dividing by a positive number. So we don't need to worry about flipping the inequality sign. So I keep it as a less than. I get x is less than negative 44 divided by 9. If we want to graph this, we'll take a number line, find where negative 44 is, or find where negative 44 ninths is on the number line. So I've got negative 44 ninths. If it helps, you can think of this as a mixed number. 44 ninths is the same as 4 and 8 ninths. So negative 44 ninths is the same as negative 4 and 8 ninths. And that's going to be between negative 5 and negative 4. And if I want to indicate all numbers that are less than negative 44 ninths, those are going to be all of these numbers over here. And I want to indicate that I'm not exactly at negative 44 ninths, so I'm going to put an open circle around where negative 44 ninths is. And that's how I specify that this is less than, not less than or equal to.